film. Some photographers and cinematographers swear by it, some hate it. Make no mistake, using film today can produce images that surpass those of professional digital cameras. But we all know there's one big downside to film: having to develop it. And if you're living in a rural area, trying to develop your film can be a hassle. So, why not try developing from home? Hello everyone, my name is Morneau, and I'm the production manager at Struts Gallery in Sackville, New Brunswick. In this video-based ad hoc workshop, we'll be exploring developing from home using household materials. Specifically, we'll be using the Caffenol process as a base recipe, and then do some experiments as a way to see if there are other household materials we could use. First and foremost, we should do a bit of research and talk about how film, specifically black and white film, gets developed, what chemicals are used, and what effect they have on the film. So, skip ahead if you don't want to hear this tedious and unnecessary information. But for those wanting to understand a bit more on how the film process works, here's a breakdown. And by no means am I a chemist, so take everything with a grain of salt. That's a pun that will make sense later. We start off with unexposed film, freshly unsealed. A transparent base, which is coated with a colloid containing photosensitive salts. In the present, most black and white film stocks we purchase today use a plastic base coated in gelatin containing a mixture of silver bromide and silver iodide. Silver chloride has also been used in film stock. These silver halides are photosensitive and create a latent image on the film with our camera through the pinhole effect. Of course, there are other photosensitive chemicals out there, but these are the most commonly used and what we see on our black and white film. After being exposed and loaded into either a developing tank or brought into a darkroom, we are ready for development. We can start with a pre-wash, though this is optional. Pre-washing helps to ensure that the film is evenly coated with developer when pouring it in. We don't want to pour in our developer and have one section uncoated due to air bubbles in the beginning. However, as we normally agitate our film right away, this is less likely to be a problem. So again, this is optional. Next, we develop. The developer usually will contain a phenol, a restrainer, and an alkaline agent. Let's go into detail about these three chemicals in developer and their effects on the film. Phenols are a class of compound consisting of one or more hydroxyl group bonded directly to an aromatic hydrocarbon group. Historically, companies like Kodak, Agfa, Ilford, Moorish Photochemie, and others have used phenols such as beerol, hydroquinone, phenidone, glycine, pyrogalol, and pyrocatechin in their developers. The latter two are stain developers, which harden and stain the gelatin on the film during development. This staining process increases the optical density in heavily exposed and developed areas, improving highlights while also masking the grain structure while maintaining edge sharpness. I also want to mention super additives. Hydroquinone and beerol are usually combined in developers, shortening developing time. Hydroquinone recharges the beerol after it is oxidized from the reaction with the silver halides. The next important component to our developer is the restrainer. Potassium bromide is used widely in many developers. Potassium bromide has uses outside of our developer and is even found elsewhere in the photographic process. It is used to create our photosensitive silver bromide, as potassium bromide is a source of bromide ions. In our developer, it helps to differentiate between exposed silver halides and the unexposed silver halides. This helps to reduce the likelihood of chemical fogging, where the chemical reaction causes our film to fog and thus be useless. Next, we need an alkaline agent. An alkaline agent is used in the developer to maintain a high pH. Alkaline agents such as sodium carbonate, borax, and sodium hydroxide are usually used and are widely available. In fact, many different DIY recipes, from DIY Rodinol to our Caffenol process, use these readily available alkaline agents. After we have finished developing, we need to pour out the developer. However, there is still developer on the surface of the film we can't just magically suck out of the tank. So we need to use a solution to stop development completely. Stop bath helps to neutralize the alkalinity of the developer left on the film, which will help fixing later. Pouring our fixing agent onto the film before stopping can exhaust the fixer, leaving our film light sensitive. Stop bath created by companies like Kodak sometimes contains a pH indicator dye like bromocresol purple to indicate when the stop bath solution is exhausted. The solution turns from yellow to purple. Extremely dilute solutions of acetic acid, citric acid, sodium metabisulfite, and potassium metabisulfite have been used in the past, though many photographers these days just use water. So now development has stopped, but if we were to expose the image to light, it would fade as we still have unexposed silver halides on the film. So we need to remove them. We need to use what's called a fixer. This fixes our latent image so it becomes permanent. Fixers also sometimes contain chemicals that help to harden the gelatin. Sodium thiosulfate and ammonium thiosulfate are normally used to fix the film, with the latter known as rapid fix, as it removes the unexposed silver halides from the film faster than sodium thiosulfate. After our unexposed silver halides are absorbed into the fixed solution, our image is no longer light sensitive. However, we need to ensure we wash our film first so that all the fixer is washed off the film. If the fixer remains on the film when exposed to light, the image can deteriorate. We can use hypoclear to help clear out any fixer left on the film, but it's not completely necessary. We just need to wash for longer. After washing, a wetting agent is used with water to remove hard watermarks and help with even drying. These wetting agents are generally non-ionic and are extremely diluted in water as the last step. So that's the full black and white process. So how does our Caffenol process compare to this? With our recipe for Caffenol developer, we are starting with 4 household ingredients: instant coffee, washing soda, vitamin C, and iodized salt. Let's take a look at each one and compare them to their commercial developer equivalent. Instant coffee contains the phenol we'll mainly be using throughout this process. This phenol is caffeic acid. Caffeic acid can be found in a lot of other foods and materials. In herbs, you can find it in thyme, spearmint, and sage. In spices, you can find it in star anise and cinnamon. In drinks like red wine, tea, beer, whiskey. Grains like barley and rice, sunflower seeds, apricots, prunes, black chokeberries, lingonberries, and more. Caffeic acid is our key to reducing silver halides to elemental silver. Remember when I mentioned stain developers? Our caffeic acid is performing as a stain developer and can be compared to pyrogalol and pyrocatechin. Vitamin C, also known as ascorbic acid, is another phenol. Ascorbic acid is a weak developer and could do the job maybe in a couple hours. However, we're interested in its similarity to hydroquinone, especially as a super additive. When combined with caffeic acid, we see the same super additive effect as adding hydroquinone to beerol. We get shorter developing times. Washing soda, known chemically as sodium carbonate, is already used in developers as an alkaline agent. It can easily be found in the laundry aisle or even in pool supply stores. However, I have been in situations where I couldn't find washing soda locally, so I had to get creative with baking soda. Baking soda, sodium bicarbonate, can be converted into sodium carbonate by heating it to 93 degrees Celsius or higher, or 200 degrees Fahrenheit for 1 hour. I will go over in detail how I do this later on. It's important to note that sodium carbonate comes in many forms, and we want to use the anhydrous form. You can convert the other form similarly to how we converted the baking soda. But do note, sodium carbonate is caustic and can irritate your skin. Also, avoid breathing a lot of it in as well. Iodized salt is being used in place of potassium bromide as our restrainer. Generally, you can find potassium bromide at pharmacies and vet clinics. However, it can be hard to find in some places. Therefore, using iodized salt in its place is much easier, as iodized salt is widely available. You can even collect small packets from restaurants and use that. We are also experimenting with our fixer and our wetting agent. We're doing this as I wanted to see if we could replace every chemical in the film process with something that's extremely easy to find. For our fixer, we'll be replacing our ammonium thiosulfate solution with a super concentrated solution of iodized salt dissolved in water. We'll be using 300 grams of salt per liter of water. You can find sodium thiosulfate at aquarium and pool supply stores, as it's usually used to reduce the amount of chlorine in pools and aquariums. It's usually advertised as chlorine reducer. However, not all towns have these stores. So iodized salt is going to make do. Sadly, this means that our fixing time is going to be a lot longer, as this concentrated solution still isn't strong enough to make this reaction happen quicker. You could raise the temperature, but for today, we're doing everything at room temperature. This is where film photographers are going to scream at me. We can replace our wetting agent, the final step of the process, with dish soap. Before you all grab the pitchforks, hear me out. We are exploring different household materials we can use. And before you say, oh well, Lucas, Kodak PhotoFlow is so cheap and will last longer than you. Tell me, if you only have a developing tank and film, and you're in a small fishing village with only a corner store with the basics, do you think they'll have PhotoFlow? We can use other wetting agents, as experiments done by others have shown great results with things like glycerin. And I've also read online of people using ethylene glycol, also known as antifreeze. But dish soap is much safer for the environment and easier to find. So we'll go with that. Ivory dish soap is the best to use, and you want to make sure there are no bleaching agents in the soap. We'll only be adding a few drops with our water at the end. So, before we start mixing our chemistry, we need to bake our baking soda. Check my phone. Okay. Well, I don't know if I'm too tall for this place or whatever. I'll duck down. So, as I said, we have to convert over our baking soda over to washing soda. So, I'm going to turn on my oven and set it to 425 and let that preheat. In the meantime, we're going to start preparing our tray here. I just have a normal baking tray, and I'm gonna take some parchment paper and lay it out so that I don't make a mess. After all, I eat off of this parchment, this tray. I don't eat off the tray. So we just want to, I like to fold the corners a bit. Just to make a suggestion, they stay. Okay. Next, I'm gonna open up the baking soda. So this is gonna be really important. Some of the differences that you'll notice between baking soda and washing soda. You'll notice the smell. Baking soda, compared to washing soda actually smells soapy. The fineness of the grain, you'll notice that washing soda is a lot finer. And then the taste. Don't taste washing soda. If you accidentally breathe it in, you will taste it, and it tastes like soap. So what I'll recommend, actually, so I would actually recommend to wear a mask when working with the baking soda and washing soda. I find the washing soda especially, the powder is so fine that if it kicks up, you can breathe it in, which is not good. We don't want to be breathing in fat powders. We're going to spread this out. And if there's any clumps, we want to get rid of it. And you want to make sure it's a thin layer. So it's probably good to become familiar with the material. Not usually with chemistry. You wouldn't want to put your fingers in it like this. This is baking soda. So in terms of a feel, on the hands, when if you have a lot of powder, it feels really smooth, but the moment that it leaves your hands, you're left with just this gritty powder on your fingers. Okay. So I want to get this sort of even out. Again, make sure there's no big clumps. See, you should be wearing a mask. Okay. So we're still just waiting for that to preheat a bit. We're gonna want to put our baking soda in the oven at 425 Fahrenheit for 40 minutes. And every 10 minutes, we're gonna take it out, and using a fork, we're going to rake the baking soda in both horizontal and vertical directions in order to make sure that all of the baking soda converts over to washing soda. So make sure I have my fork in hand. And we're ready to put her in. Yeah, it's getting nice and hot there. And we'll start the timer for 10 minutes. And in 10 minutes, we'll take it out and rake it. So our first timer just went off. So we will put our mask on. Again, the mask is not very necessary, but I'm just being careful.
And we're just gonna take our fork and rake back and forth. This should hopefully break up any big clumps too that are starting to form, because we don't want that to happen. And actually, if I look at the baking soda right now, it does look a little bit different in terms of texture than it did when it went into the oven. Whoops. So back in for another 10 minutes. Let's set our timer. Okay, so we're now approaching the end of our 40-minute mark of converting over the baking soda to washing soda. We have about 30 seconds left. From my last raking at the 30-minute mark, I did notice the texture was different than from the beginning. So I suspect at that time, at least the top layer, if not all of it, had converted over. So hopefully by the end of this chime, coming up in a sec, we'll see washing soda. So, yeah, so this looks very fine. I will just get a glimpse here with my camera. So as we can see here, it's really fine and kicks up a bit easier than what the baking soda did. I'm thinking that's converted over, so I'm gonna turn off my oven here. I'm gonna let this cool down a bit, and then I'm gonna transfer this over to a container. I would recommend a container, something like a butter dish or a margarine dish. Yogurt containers are great. You want something that's gonna be able to contain the amount of baking soda that you had. So I had 500 grams, and you can pretty much easily fit this in here. And if not, we're gonna be using this sort of right away. So at least we can use some of the leftover stuff, if not stuff from the container as well. So after this is cooled down, I'm gonna transfer it over. I'm just gonna probably transfer it by funneling everything with this paper here. And then we're gonna start mixing our chemistry. Okay, so we've come to the part where we're going to mix our chemistry. The first thing we're gonna do is mix our fixer. The reason why we wanna do this is because we're working with a super saturated solution. So we are mixing 300 grams of iodized salt per every liter of water. So if you're developing with 500 milliliters, or if you're fixing with 500 milliliters, you're gonna need 150 grams of salt in that water. So first things first is I'm going to start my tap here. This could get a little bit loud, but what we wanna do is get our temperature around room temperature. I find it's always a little easier to have it slightly below if possible. Here I'm at, I'm up at 25, 26 here, so I need to knock this down. Of course, you can choose to develop with a warmer infix with warmer temperatures, and that will cut your time down. But if this is your first time, it's best to stick with a 20-15. 20 degrees, 15 minutes. So we're lowering here. We're getting down to 24, 23, Oh yeah, here we go. So I'm gonna fill up my container here. And I have about 50 milliliters, so I'm gonna let that run still. So we're roughly at 20 degrees, 21. That's gonna be good. You know, by time 15 minutes comes around, hopefully there will be some evening out with the room temperature as well. So we're at roughly 21. I like to use these yogurt containers. They can hold about roughly 500 milliliters or a bit more, which if I'm developing one roll of film, I need 500 milliliters of solution. So that's perfect. So I'm going to weigh out 500 milliliters, or 500 grams, sorry. I'm pouring here. Just passing 300, 400. Okay. I'm at 471, 481, 87, 491, 495, 497, 98. And 500 grams. So that's my water. So I'll set that aside. Make sure to tear off our scale, zero it off. Okay, open our salt. And because we're working with 500 milliliters, we need 150 grams. Oh, there was a little spout for there too. Didn't know that. Oh. I feel like this video is just going to be me trying to open this box of salt. There we go. Okay. Gotta turn the scale back on. And 150 grams of salt. Just passing 50 here. Okay, and I'm a little over. There we go. I'm just gonna pinch that out and throw it in the sink. It's just salt so it doesn't matter. We're now gonna take our water and we're gonna dissolve our salt into it. I do recommend having a mixing device that is separate from your developer mixer. So I like to use this dowel for my developer, and then because I'm just using salt water here, I just like to use like a spoon. So we'll dump our salt solution in and start mixing. And you want to mix this until everything looks clear. You also want to sort of not feel any grains at the bottom of the vessel. However, if you keep mixing for like 15 minutes and it doesn't disappear, that's fine. You know, I believe it's, you know, a little bit after 300 grams that you reach super saturation, so you're gonna have problems anyway. Okay, so my solution here is starting to clear up. I think we're at the point now. I'm just gonna let it settle for a second. I still have some salt grains that I can see, so we're getting there. It's actually kind of good to use a spoon when mixing your salt-only fixer. because of the fact that when you pick up your spoon, you can take a look and you can actually see some grains of salt if they haven't fully dissolved. So, yeah, we're still getting there. And, you know, people might be asking if we should use, you know, distilled water, tap water. You know, you're going to get the best results with distilled water because you're not dealing with any other minerals within that water that could affect the film. However, I don't care. I honestly, as a photographer, even though I love the idea of having archival prints and all that, I'm also very much into experimentation. So I just like the process of doing this. I feel almost like a little witch. And this is my little magic spell. So we've dissolved our fixer. We're gonna leave that to the side and let that settle just to finish dissolving. And now we're gonna start weighing out our chemistry for our developer. So now that we have our fixer mix, we need to mix our developer. So we're gonna be using 4 different materials for this. So first things first, because we're using Caffenol today, we're gonna be needing instant coffee. I bought one of the cheapest ones I found, and you want the cheapest one you can find because more likely it will be more acidic, and we need that acid to help develop the film. So that's one thing. We're gonna need vitamin C. I have crystals here already. I don't have to break them down, so I'm set. We have, this looks like margarine, but this is our washing soda that we just made. So there's that, and then iodized salt again. So the first things first, we're going to measure out our washing soda. Again, I'm grabbing a mask. I know this is gonna kick up a little bit. I don't wanna breathe it in. And having a little bit of protection helps. We're gonna use a different container. We'll use this one. Tear it off. And because we are mixing 500 milliliters, oh, I went a little bit over. We need 27 grams of washing soda. So, and you can probably see how much dust that kicked up. I can taste it. Washing soda is quite fine and is a bit caustic, so you'll want to be careful with that. Next, we're going to mix our vitamin C. Again, because we're mixing 500 milliliters, we're going to need 8 grams. So with washing soda, if you're mixing 1 liter, it's 54 grams. Because we're mixing half, we use 27. And for 1 liter of chemistry for developing, you need 16 grams of vitamin C. Though for today, we're using 8. So turn on my scale. Seven. 8. There we go. And I do like to organize these by when I put them into my chemistry. So I pour my washing soda first, then my vitamin C. Next is my salt, which we need 5 grams of for 500 milliliters. So if you're mixing 1 liter of chemistry, you need 10 grams of salt. A little bit over again. There we go. And finally, we need to get, there it is, our container for our instant coffee. If we're mixing 1 liter of chemistry, we need 40 grams of instant coffee. If we're mixing 500 milliliters, we need 20 grams. So that's what I'm gonna measure out. Oh, we're just a little bit over. 19. There we go, 20. So, now that we have all of our dry chemistry ready, we're gonna get our water ready. Again, we need an empty container, and we're gonna fill up 500 milliliters of 20-degree water. When we whisk our washing soda in, there is going to be a bit of an exothermic reaction. So it might actually be better to be a little bit colder. Okay, so my temperature is reading around 19. So that's good. The exothermic reaction is going to help warm that up a little bit. So, oh, no, that's not what we want to do. We want to weigh it out. So we're at 466, 482. 499, 500. Perfect. So now here's where the fun starts. I'm gonna take this off of the scale and put it onto the rubbered mat, just for mixing. And you can put your scale away now too. So first I'm gonna take the washing soda. Here's my washing soda. And I'm gonna start stirring and pouring it in. You can see all the dust kick up around it. Kind of lean back. If you have ventilation, turn it on. Again, it's just the powdered washing soda I find is kind of freaky. Yeah. I'm tasting it right now. So that tells you how easily it can spread out in the air. So mix this. You might start to feel crystals form on the bottom from the washing soda, and break those down if they do. And once that starts to clear up, I'm going to grab my vitamin C. It should fizz up a little bit. After that, I like to take my salt. Clean those out a bit. And finally, this is gonna be the most disgusting part, I will say. The smell of Caffenol turns my stomach. And it's gonna be easiest for you to slowly pour in the instant coffee, stir it in, make sure it dissolves, and then pour more in. I find if you try to pour all of it in at the same time, it doesn't dissolve properly, or it just takes a long time to dissolve. So we're doing a good job here. So bad. It's so bad. Make sure we kick all that in there. So this is gonna be a nice dark brown color. Don't drink this. Do not drink this. For the love of God, do not drink this. Yeah, the moment I started working with Caffenol, it turned my stomach from instant coffee, like, immediately. So, we do have a little bit on the sides of the cup. So I'm just gonna kind of kick those around a little bit. Okay. So once it looks like things are dissolved pretty well, we're going to let it continue to dissolve and mix together for the next few minutes. You don't want to mix this and leave it for a couple days. You want to use this almost right away. But now we're going to quickly just wash this up and then load our film into our developing tank. Okay, so we've reached the point where we have to take our film and put it in our developing tank. So if you don't know how to do that, I'm not going to show you here right now. There is videos online produced by other people showing how to put film on a Patterson tank. In the future, if you want me to do a quick video, I can. But for now, I'm just going to find a dark space in my house, somewhere that there's no sunlight, and roll up. You can also use one of the dark tents, per se. They're a sort of sleeve situation that you put your hands into and change. I prefer to work within a dark room personally, and I find what works best is to find a bathroom with no outdoor light and to hide myself in the tub. So that's what I'm gonna do right now. So you'll probably hear me swearing. I might leave some of that in for the end, but for now, I'll see you in a second. So I got my stuff on there. I guess a face cloth fell on me. Just make sure that the area is not wet if you're using a bathtub like I am. But that's loaded up. We're gonna go to the sink now. Okay, so make sure there's nothing in the sink here. So now we're gonna start our process of developing. I'm going to start off with a pre-wash. And my pre-wash is going to be 1 minute, continuous stream of water at roughly 20 degrees. I do tend to go a little bit colder with my water when it comes to my pre-wash, which is just to wet the film. So, put the top there, and now we wait. I'm gonna set a timer on my phone too. I find using timers on phones like this so helpful these days. Just make sure that you have the setting turned off your phone that, you know, after 5 minutes it turns the screen off. You want it to stay on for at least 15 minutes, because otherwise the screen could turn off while you're developing and confuse you. So we're just hitting here the 30-minute mark, or 30-second mark, sorry. And because of that, I'm just gonna move these containers out of the way a bit. I'm gonna grab my developer. Bring this top a little bit. 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's clear. And when we pour it, we can see at the bottom that the water does turn a bit bluish black with HP5. So we can see we're starting to dissolve some of this stuff off here. I'm gonna set my timer to 15 minutes and start pouring. Whoa, I spilled a bit. We want every drop of this. Oh yeah. Okay, close this up. And I'm gonna agitate this until I reach my 14 minutes and 30 seconds mark. So the first 30 seconds, including the pour, is agitation. And when I'm agitating, I'm spinning the bottle slightly in my hand, or the tank. There we go. Just clean off that container there. And I'm gonna agitate now every 30 seconds for 5 seconds. And I'm gonna try to invert my tank about 5 to 6 times. 5, 4, we're reaching the first agitation here. 1, 2, 3, 4, 5, 6. And when I'm done agitating, I smack the bottom either off the side or the bottom of my sink. And that's gonna help any air bubbles that are on the film release. Because what would happen is those areas would just not develop. They would not have developer touching them. So you just have spots in your film. You have to be pretty attentive with this. It isn't really a problem. So we have about So we have 1 minute left. Because of that, I'm going to start getting my water ready. Our next step is to stop the developing. And historically, people have used stop bath, which has an indicator built in to tell you when it's exhausted. But you can also use water. We're at our last agitation here. We have 30 seconds left. I'm gonna take off the top. We can see everything's nice and bubbly. Oh, the smell is horrible. 7, 6, 5, 4, 3, 2, 1, and we can pour it out. In a perfect world, I would keep all of that developer and dispose of it properly. However, this is not as nearly as bad as the environment than normal developer. It still has silver in it, which is an issue. So if you wanted to, you could collect all of your developer and fixer, let it evaporate, for example, so that you end up with a product that you can dispose of easily. I'm also gonna just invert this a bit. I just want to make sure I get all the coffee out. I'm also gonna make this a little bit colder. Dump this again, and we can see when we do that, we're still getting some of the coffee stained water coming out. So we know that the film is maybe stained, but we'll hopefully get all of that out before we put our fix in. Okay, and once this fills up, I'm gonna pour our fix in. So this is our next step, our fix. I mentioned that this video is gonna take a few days. That's because we have to fix for 48 hours. You heard that right, we're fixing for 48 hours. So, my fix. It's the super saturated solution. Close that up. We're gonna agitate. I'm gonna agitate like 30 times just to get this all nice and mixed up. And then I'm gonna agitate it every now and then for the next 2 days. You know, it could be every hour. It's not gonna be every hour. And I say this is about good. Now, again, we'll check on this over the next 2 days. I might just shoot normal iPhone video for this, showing you like updates, but we will see salt crust forming on the tank. And don't be worried by that. It's not going to damage your film. Worst case scenario, you might have some spots that are burnt by the salt, but that's why I want to agitate to make sure we're mixing the salt together with the water. So I'll see you in 2 days. Hi, and welcome back. We are a few days later after we started developing, and now I just cleaned up the dishes, and we are ready to finish this fixing. So, first things first, we should agitate it just in case. So first things first, we have our developing tank here with fix in it. We can see that the salt crust has formed around the film container or canister. So we know we have this supersaturated solution. There is unexposed silver that is washed into this solution, and we shouldn't dump it down the drain. Sorry, we shouldn't dump it down the drain because the fact that it's not environmentally friendly. So I like to take a container and allow the liquid to evaporate. A lot of times I find what's helpful is taking some steel wool, put at the bottom of the base so that the silver attaches to that, or it forms different participate. So it's gonna be easier to deal with. But yeah, long story short, you do not want to dump your fix down the drain. So I have this container here, and this is where I'm gonna store my fix. I'm gonna open this up. Ooh, it's crusty. And then we're gonna pour it in. It's not looking too bad. And now we're gonna wash for 1 minute. We're gonna take a look, and then we're gonna wash for another 15 minutes. So we're just washing all of the fix off. At this point, it's okay to take off our lid. And we're gonna take a quick look at our film and how it is. Before we do anything else, after we take a look though, we need to wash for 15 minutes. That means this drain's gonna be running for 15 minutes. Let's take a look. And as you can see, we have exposures. So our film worked. I'm gonna put this back in and let this wash for 15 minutes. I'm gonna set a timer on my phone. And we'll see you soon. So we've just reached the end of our developing. Our film is washed for 15 minutes. And now this is where we use PhotoFlow usually. PhotoFlow, in my opinion, is a fancy soap. So I'm just gonna use a little bit of dish soap. I like to drop just a little tiny drop in, and I agitate this a little tiny bit. If some bubbles form, you want to scoop those off because there is a chance those bubbles could end up on your film. You don't want that. You don't want that. You know? Because the suds of the soap could just dry on, and then all of a sudden you have little rings on your film. That's not pretty. So we want to wait about a minute for that to soak in. Okay. In the meantime, So it's been about a minute. I'm just gonna dump a little of that water out. And here's our film. I burp at the same time. Here's our film. So you can either pull it off. You can also twist these batters and tanks and they'll come off. So that way you can easily peel your film out, grab an end. Well, looks like we crinkled it a bit while developing. So we're gonna wipe it down one way. Flip it around, dunk our fingers in the solution again. And the second way. Okay, and now I'm going to bring this to somewhere to hang. I like to use, usually I put it in my shower. I hang it with some clothesline pins.
So we have negatives. The first noticeable thing we can see is how our film has stained. This won't affect the colors of our scans as we're working in black and white for that process as well. But if we were to be developing paper prints, our print would be similar to a sepia tone print. This staining process is one of the allures of Caffenol. We can also use other phenol-containing solutions that will stain our film and prints with different colors. Our film looks perfectly developed, so there's no need to change this recipe. We'll be using this recipe as our control, only substituting the water and the instant coffee. Next, let's try developing with red wine.
So first things first, what we're gonna do is mix together our chemistry. So if we recall, our fixer worked great, so we can use the same amount this time around. So that means we're gonna need 150 grams for 500 milliliters of solution. So let's get a container out and our scale with some water. So again, the first thing we want to do is measure the temperature of our water. This water is a little warm. Yeah, it's really warm. There we go. We're pretty close there. We're on 21 degrees. Get my salt. So again, we need 150 grams. $150 grams. Let's tare that. And 500 grams of water. $500 grams, perfect. So we have that. And let's mix that again. Okay, so we're getting to pretty good clarity here. Yes, that's good. That's good. That's good. Okay, so we now have to make our developer. Why am I walking away? And I pre-poured my wine. I poured out 500 milliliters of wine, which is 2/3 of a bottle of wine. Is this an economical way to developing film? No. Is this insulting to winemakers? Maybe. So it's probably best to use wine that's been out for a long time, or if you get a bottle that's corked, for example, that's gonna work perfect for this. I just have a bottle of cheap red wine. It's pretty strong. Let me take off this saran wrap. Oh yeah, I put an elastic on here, I forgot. There we go. Yeah, that's wine. So we have that measured out already. You're probably gonna have less problems mixing the solution versus mixing the Caffenol, and that's because you had to deal with the instant coffee. So with this, we have our 500 milliliters of wine. We're gonna need 27 grams of washing soda. We need 8 grams of vitamin C. And we need 5 grams of salt. Here. We'll take our wine out because we'll mix it into here. First, we'll mix in our washing soda. And you'll notice when the washing soda hits, it'll turn blue. Really strange reaction here. So, yeah, I guess I'm gonna have to show you. When you mix the washing soda with the red wine, it's gonna turn a bluish purple color. So as you can see there, that's no longer red wine. We'll now add vitamin C. And that's literally bringing our color back. I have some vitamin C stuck on the bottom, so I'm just gonna make sure to get all of that out. And now, finally, we'll add our salt. And mix that up really well. And we'll let that sit for a few minutes while we load up our film for developing. But this has changed color dramatically. So don't be shocked if yours changes color as well. We have our film loaded in our film canister. So now it's time to pre-wet. Minutes. And let's pour it in. Again, so like last time, for the first 30 seconds, we want to pour and agitate our film. And again, I'm doing this twisting motion when I'm agitating, so I'm not agitating back and forth the same side of the film constantly. We're making sure all the film is coated. Let's open this up. Ooh, that's a nice color. Ooh, this smells bad. It smells like bad wine. I wouldn't drink this wine. 3, 2, 1, and we're dumping it out. Whoa, look at that color. So now we're just washing our film. We're stopping the development. And we're gonna rinse it like this for 1 minute. And then we get on to fixing. And again, because we're doing our good old saturated salt solution mixture, we will see you in 2 days where we'll take a look at this film and see if it's developed. And we're done our washing. We can see our water comes out pretty clear now, which is good. We're gonna dump our salt solution in. And we're gonna start agitating. I'm gonna agitate probably around 30 times. Do the agitation dance. Shake that butt while you do the agitation dance. 7. And we're done. And we'll see you in 2 days. And we're back. So I'm just gonna agitate this a little tiny bit before I pour out my fix. You can see we have our little salt crust around here. Oh yeah. And I'm gonna pour this into my waste container. Looking nice and full. And now we'll wash. Again, we're gonna wash for about a minute, and then we're gonna take a look at our film to see if it's developed, and if it's fixed. And then we're gonna do our final washing with our photo flow or our hand soap, our wetting agent. I'm going to turn the heat down on this. It's a little warm. That should help to get some salt off, but we do want this closer to room temperature. Okay. The moment of truth. So it looks like we have some thin negatives. Yeah, so we have shots but they're quite thin. So we'll talk about how we could fix that in the future. But for now, let's just finish washing these off.
As we can see when we took the film out of the developer, developing with our Wineol mix at 20 degrees Celsius for 15 minutes created thin negatives. Remember that the photos were captured with the same aperture, shutter speed, ISO, and lighting conditions. I would even ensure that we were exposing properly with a light meter. So, what could have caused our negatives to not fully develop? Well, let's take a look first at the main differences between our Wineol versus our Caffenol. Mainly, we're using a solid with the instant coffee, dissolving it last in water. Why do we dissolve it last? According to the Caffenol cookbook, during the mixing process, we need to convert the ascorbic acid to an ascorbate salt with mixing it in our alkali solution, releasing CO2 in the form of bubbles. Because we are using red wine straight away and mixing our dry chemicals into the Wineol, the ascorbic acid may not convert to ascorbate salt. But I honestly think the main culprit is the amount of caffeic acid in the red wine. So, what can we do to make sure our negatives fully develop? We could increase the developing time, ensuring all of our exposed silver halides are converted into elemental silver. But we also don't want to overdevelop our image. We could add more ascorbic acid, adding more phenols to our mixture to ensure everything is developed in 15 minutes. But adding too much could also overdevelop or even affect the pH of the developer. So we would also have to add washing soda. We can increase the temperature, speeding up the conversion process. However, we need to ensure constant temperatures if we're increasing the temperature. Something I don't recommend one tries doing from home without something like a sous vide heater. So this recipe still needs to be built on. But as you can see with our experimentations, things are working out. Using the Caffenol process as a base, we can modify it to fit our needs. And comparing our shots to a DIY developer control allows us to identify problems much quicker. I'll probably be doing more experimentations with this process in the near future, though it is a bit more expensive than coffee, so I'll probably hold off for now. Next, let's take a look at beerol.
So now we're moving on to our last recipe for this portion of our experimentation. So we first did Caffenol and received great negatives. And we just developed our Wineol negatives, and those were a bit thin. So we know with the Wineol, we're gonna want to do something to get those negatives a bit more dense. Our next chemical we'll be using, or household item, is beer. I picked up Moosehead Alpine. This is a local beer to New Brunswick. I am not from New Brunswick, and I've only learned that Alpine is from here. Being from Newfoundland, I'm used to drinking, India, Kitty Bitty, Black Horse, Blue Star. So this is new for me. And clearly I'm not going to drink it. I'm going to develop with it. We do not have 500 milliliters though. So we're going to end up watering down our solution. I kind of already have a feeling that this could affect the density of our film. So here's our decision. Do we decide to add to our chemistry? So do we add something else to help boost the developing power? Or do we pray that even if we're adding, 25 milliliters of water, that doesn't affect our film that much? This is where our experimentation leads us, really. It's our decision to figure out if it's going to work. So I'm not going to change anything. I'm not adding any more chemicals besides the new beer instead of instant coffee. and a little bit of water to fill it up to 500 milliliters. We're staying to the same amount of ascorbic acid and the same amount of washing soda and the same amount of iodized salt. None of that is changing. So let's get to mixing our chemicals. So again, the first thing we're going to need to do is mix our fixer. So, I am currently pouring my fresh beer into my container. And what I am facing at the moment is some bubbling, some fizzing, which we usually get when we pour beer. We get a beer. When we pour a beer, we end up with this head on top. And that's not going to be good for us when we develop. So, we kind of want to leave this out for a bit to get a little stale, get a little flat. I also add a little bit of water just to make sure we get to the 500 milliliters. You know, stir up your beer. We want to make it flat. Okay. So now that we've stirred up this beer quite well, you know, I've gotten rid of a lot of the carbonation. Will whisking just bring more air into it? Nah, we're good. So now we have to weigh out the rest of our chemistry. And we already know what most of that is. We need 5 grams of salt. So now, I'm going to keep this on while I mix. We're going to add the washing soda to our beer and water mixture. Next, we'll grab our ascorbic acid. And then our salt. Just wash out those containers. And that's our developer. So this one, in comparisons to our other ones, is quite clear. We still maintain the clarity of the beer. You know, the washing soda didn't add any opaqueness to it, nor did any of the other chemicals. So we'll see how this one reacts. And let's go load our film. I'll be right back. Well, we're back. You know what that means. It's time to develop. We're gonna start our pre-wash. I don't think we need our can anymore. Oh, yeah. Don't smell that. Oh, shit. That's bad. That is naughty. If anyone were to be mistaken and try to drink that, oh, I feel bad for them. Okay. You see the blue at the bottom. Ooh. Okay. In 15 minutes. So we have one more agitation left, and then we're going to move on to our stop bath, and then we pour in our fix. And then I'll see you in 2 days. So here's the last few agitations. Take off the top. Ooh, we can see it's quite foamy. Oh, that smell. I'm not going to get used to the smell of any of these. And we can pour it out. And I mean, it looks yellow. And we will just go ahead and rinse this. Now, I'm interested to see if there's any staining effect that we get on this film like we get with the caffeic acid in the Caffenol. And from what I can see, a little bit of the caffeic acid in the red wine. And whether either elements of those drinks, whether it be something in the instant coffee that stains the film, or if it's actually going to be something like just the caffeic acid itself. Okay, let me grab my fix. And only time will tell. Again, you want to agitate this for about 30 seconds. Okay, and we'll see you in 2 days. And guess what? It's 2 days later. So I'm going to prepare and take my fixer out. Oh yeah, that's nice and salt crusted. I'm gonna turn some water on just to start washing things. The solution's quite clear, with a bit of like a pearlescence to it from the sodium, or from the salt, sorry. Let me get my water to temperature, and we'll start our wash. So I'm gonna set it for a minute here, and then we'll take a look, and then finish our wash and the wetting agent. Probably take off the light lid in a moment. I'm pretty excited to see this one come out. You know, I've done Wineol with printing before, so I did expect to see an image when the film came out. Was I disappointed by the thinness of the negative? Yes, but it was sort of expected. With this, I'm sort of going in blind. I have seen beer be used before, but I've seen people use Guinness. So this is more of a lager. We'll see if it works. Setting the timer for 15 minutes for washing. We'll take a look here at our prints. And we could actually fix longer. Yeah. I think there's issues with... We'll see. We'll see there. I think there might have been some issues with the fix. push record? I did. So, I took this out of the fix and washed it. I have a theory of what might have happened after closely inspecting the film a little bit. I think, and this is something that happened a little bit in the Caffenol, this is something that I realized after a little while, is that there's a foaming action that happens both... There's a foaming action that happens both with the Caffenol and with the beer, especially with the beer. And I think that caused the film to not properly develop on one side. In this case, we can see that one section of the film is a bit purple, but there's also some air bells. And you can see that the text, the film information is a little faded, or it's just not as developed as well as the other side. So let's go bring this over and let it dry, and we'll have a discussion about what happened.
So we have a few things happening with this film compared to the Wineol and the Caffenol. First and foremost, we see this gradation of density on the film. This, along with the air bells on the thinner areas and the differences between the film stock info on both sides, makes me think that we have an issue with foaming. Foam caused our film to develop unevenly. You know, when using 500 milliliters of developer for a roll of 120 film, you're really playing Russian roulette with air bells, especially with DIY films. So, next time, it would be best to both let the beer sit out for a long time to ensure it flattens, and to use more beer. But then we're using a lot of beer, right? The second issue is that our negatives are again pretty thin. It's hard to tell in person, but I would say the beerol and the Wineol developed with the same strength developing power. But the red wine stained the film significantly, so it has this darker appearance. So, to increase the developing power of our beerol, we could, again, either raise the temperature, increase the developing time, or add more vitamin C and washing soda. Remember that if we are adding vitamin C, we are lowering the pH and making our developer more acidic. Therefore, we need to compensate with more of our alkali solution. We tried developing our film in 3 different recipes and got 3 different results. However, we still don't know what they will look like when we digitize them. Let's take a closer look at the film with our scanner and see if these negatives are workable. And let's take a look at differences between them.
I have my instant coffee here. This one here is my Wineol. And this one here is the beerol. So let's take a quick look at all 3 of them and just talk about some of the things that we can notice about the film. So as we know, the Caffenol was our control. We already know that Caffenol works as a process. Now, there is one thing I do want to note that I see personally on this negative, and it's across all 3. And it's one of the issues that shows up a lot in the DIY developers. So we can see that this area here is a bit brighter, but at the same time, we can see how right here, it also gets brighter, you know? Same thing over here. We have it on top with some glowing spots. And we get a lot of it here where you can even get some weird tonalities, like these little spots here. And that's actually from developing. The foam of the byproduct of shaking and agitating the developer, because the fact that we were using 500 milliliters of developer for 120 film, one roll of 120 film, the developer was basically just at the top of that reel. So any foaming would cause areas of the film to not develop properly. So even though you're agitating the film and it's getting washed in chemistry, that chemistry is then through gravity moving down and foam is replacing it, and that's not really doing a developing job. And in fact, we end up here with the beerol with some strange little dots that form on the film. There's also some other things we can talk about the beerol too, but we'll get to that in a bit. You might be wondering why these look pretty flat. So when I do scan my film, as we can see with the histogram, I try to ensure that I am maintaining my complete range of tone in that histogram. So I don't want to scan and end up clipping off so much of my shadow detail or my blacks. And the same thing with the highlights. That's something that I will bring into my print during post. So for example, if I were to go and change my highlights and shadows and to move these around so that we end up, with, blackest black and brightest white within our print, this is why I've brought this color checker in, because we have a card here used for white balance and then our medium gray. So I could technically get my perfect exposure through that if I wanted to, and then make sure my whites are bright white. So you can go in and try to get those blacks there. I'm going to turn that off so we can see here our print's starting to look a little bit better. But we can see that we don't have this range of tones like we do with the Caffenol. This jersey here, this yarn right here is black. This is a off-white. This is a bright red. So we can see that with our control image here, the Caffenol, we're able to get a broad range of tones. And that's because our film is developed properly. Whereas here, because we have underdeveloped prints, we're stuck with a very narrow range of tonality. And then that just means that, as we can see, it just disappears. If we compare the black here of the plastic of the color checker even to the fabric, there's not much tone differences, We can see there's quite a big difference here compared to here.
To sum everything up, we now know what we need to look for when developing film with a DIY recipe. Phenols will reduce light exposed silver halides into elemental silver, and thus we need to find something that contains phenols like caffeic acid and ascorbic acid to develop our film. Red wine and beer would work perfectly with some more experimenting with our concentration of washing soda and vitamin C. But these processes can be quite expensive compared to instant coffee. Before I finish off here, I want to give a special thanks to a few notable people who helped push photographers to use household materials. First and foremost, it was through Dr. Scott Williams' technical photographic chemistry class at the Rochester Institute of Technology that Caffenol was developed in 1995. Without their initial experimentations, we might not have discovered this process. The creators of the Caffenol cookbook are also a huge part of Caffenol's story, creating a document that is used by most Caffenol beginners. There are also photographers and chemists who've been instrumental at sharing experiments, advice, and knowledge in forums such as the Photo Forum, Photo Trio, and many others. One blog that has been extremely helpful with non-coffee Caffenol has been Daggy Brundert's Caffenol blog. Their experiments with materials from rosemary to seaweed has me itching to experiment this summer. And personally, I want to thank two people who showed me how to develop with household materials. Jennifer Crane, who was my master's thesis supervisor and photography professor, and Barbara Reimer, who is the photo technician at the University of Saskatchewan. Barb, especially, has been working for years with Caffenol and has helped me so much with the process. Jennifer's Alternative Processes course has been one of the most useful and influential courses I've taken in my life, and I cannot thank her enough for guiding me through the processes like gum-bichromate, palladium, and many more. For those wanting to know more about Caffenol, links are in the description. So the final question I have left to pose: is there a more cost-effective way to develop film? Can we forage perhaps for ingredients? That's something we'll have to figure out in the summer. I also want to see if there are other homemade fixer recipes. One I came across uses our concentrated salt solution with about 2 milliliters of household bleach or sodium hypochlorite. According to this photographer, the bleach shortened the fixing time to a few hours and worked on tea grain films. I'll have to do some tests and see if it works. Until then, I'm Lucas Morneau for Struts Gallery, and I wish you all the best and happy developing.